well, we've got about 50 people who've joined the call, so I reckon we should get started. So Tracy, can you unshare your screen?
I can.
And if we all come off mute, welcome everybody. Hopefully you're seeing us. Tracy, I'll hand over to you to open and set us off.
Sure. Hello everyone, welcome to this Macclesfield Eco Network event. It's our very first how-to webinar that we've organised. My name, by the way, is Tracy Kelly. I'm the chair of Macclesfield, and Lynn Jones is very kindly helping to organise this event and run it. This event grew out of a conversation that we had in the Eco Summit in May this year, which we co-hosted with Mac Town Council. So there was a lot of interest that was voiced that day about how to retrofit your house. So we said, well, it would be a really good idea to see if we could put something on. So that's what we're doing this evening. And the event will be recorded. So just to let you know, and I'm going to hand over to Lynn, and I think Lynn might explain a little bit how we're going to do Q&A.
Yeah, thanks. So hopefully there were more than 100 or so people that had signed up to join us, so that's brilliant. Loads of them in Macclesfield area, quite a few in Hemel Hempstead. Cheer for Hemel Hempstead. People from Crewe and London and all over, so lovely to have you. You're all very welcome. So the idea is to really think about how to get started in reducing carbon consumption of your house and also making it a more comfortable kind of environment to live in, warmer maybe, basically. And from the conversations that we had back in May in the Eco Summit, people were just saying they didn't really know where to start, didn't know where to get independent advice from, and to find experienced contractors, and then also concerns about the cost, of course. And we know that the government's Green Homes grant last year was a bit of a disaster, but there is now £5,000 promised from, I think, next April that the government's going to be offering for replacing your gas boiler with a heat pump. But is that the right place to start? And Cheshire East actually has its own Green Homes grant for households with an income of less than £30,000. But again, you know, what is it that you might want to do with your home? So we're not going to go into a lot of detail on funding sources or argue about whether or not the government should be doing more. We probably all have our own views on that. And we won't be recommending kind of individual contractors, but you obviously can use a Macclesfield discussion page on Facebook for that. And we can't promise all the answers, but we do have a fantastic panel. So first of all, going to introduce them. I know that they are all personally very passionate about climate change, and they've all been working on their own homes. So in alphabetical order, Florence Collier is a mechanical services engineer who spent 20 years advising on energy demand and use for the multinational Arup. She's now running her own consultancy, Humblebee, is a passive house expert, and advises on creating low energy homes. And I think you're just about to start working on your own house in Wilmslow. Is that right, Florence?
Yes, that's right, yeah. We've tried to do a bit of loft insulation ourselves, but we've got a larger project coming along. So yeah, hopefully starting in February, although we put the application in planning back in June, I think, and we've only just had a visit from the planning officer, so it's just ridiculous.
Okay. Yeah, not so straightforward. Nick Parsons. Nick has had about 40 years hands-on experience in sustainable buildings and renewable energy, initially for a housing association, then running a community project in Sheffield, and now as an independent advisor, freelance tutor for CAT, Centre for Alternative Technology in Macclesfield in Paris, and the Carbon Co-op in Manchester. And so how many years have you been working on your house, Nick?
Oh, a mere 34.
Have you finished yet?
No, I haven't finished. Although I have, theoretically, I've semi-retired, although I haven't actually noticed having any spare time. So I've been doing something wrong. But the aim is to spend most of next year externally insulating part of my house and building an extension.
Okay.
Yeah.
Right. So that's
insulated.
lots of good experience of how to work in your house while you're living in it, which might come. And then lastly, Eliot Warrington, who's based in Macclesfield, who a lot of you may already know, founded Solarcrest as a whole house retrofit store, and he specialises in building fabric insulation and heat recovery systems for refurbs or self-build. And for those of you who know that Eliot lives and works from the medieval steps and the steep slope of Brunswick Hill. How did you get the stuff up there? Must have been a bit tricky.
I don't know, it seemed like a good idea at the time.
And you did yours. When did you do your home? It was a long time ago.
I bought it in '97. I spent 10 years renovating it, and I got to the end of that project. And then I realised what energy efficiency was all about, and realised I'd done it all wrong. Did everything all over again, took the roof off again.
Oh, wow. Okay.
Yeah, everything the hard way as usual. But now it's lovely. It's lovely now. It's very, I pay as much in a year as I used to pay in a month on heating it. And it's healthy to live in. There's no damp, mold, condensation. And I wouldn't still be here if I hadn't done what I've done to it. Now it's my forever home.
Right. Okay. Thank you very much.
No further notice.
Thanks. Thanks for being here. So let's kick off. Just to tell everyone who's on the call that you use the chat, you should be able to see the chat function, use that for talking to each other. If you want to put a question in, there's the Q&A function at the bottom there. Tracy's going to be watching that. We have had quite a few questions in though. We're going to start with those. But before we do that, I just wanted to see if we can find out a bit more about the audience. And you may have already picked up that Tracy and I are very experienced and competent at running these kind of webinars. Not, but we're just going to try a poll, see if we can make this work, which means it should pop up on your screen. It should say your retrofit plans. Tell us, what are you doing? Is it underway? Are you starting shortly? Is it still at the research stage? Haven't decided yet. It's probably just a daydream, might never happen, or it all depends on the cost. Where are you? So we've got a bit of an idea. Just give you a couple more seconds. Right. Okay. I'll close it just because so we can move on. So I think, look, we're still at the research stage. Over 63% saying still at the research stage, and 3 people say it's probably just a daydream. Right. Okay. I like that. So we also wanted to ask you a bit about your home. So when was your home built? So we've got just a few random dates. I don't know if there's significance to those dates in terms of building or construction terms, but how new, how old? And I gave the option at the end there, no idea, but it's old. Or perhaps I should have said cold.
Yeah.
Yeah, the ones built since 1990 are about as bad as the ones built before 1850.
Absolutely, absolutely, yeah.
Okay, so there you are. I'll end that one. So there you are, panel. That gives you an idea of your audience, what kind of age. It's quite a spread, actually, isn't it? I thought there might be more older.
We're not seeing the spread. Though.
Oh, you're not.
No.
I'm sorry. Okay, so share results. Do you see it now?
Yep.
Oh, right. So there you go. And,
anything past 1930's probably got cavity walls, just for information.
Okay, yes, right now. Stop sharing that now. There's one more before we move on. So the type of property. So what kind of property are you in? Terrace, detached, semi-detached, purpose-built, converted, old cottage, farmhouse, barn, and a listed building. I don't know if there are options to tick 2 boxes. I can't remember now whether I did that. And then is anyone lucky enough to be dealing with an unoccupied house? Because that's what I think. Okay, so most people detached, semi-detached. Oh, actually, I'm going to end it and share it. Shares, there we go.
Yeah. Okay, right.
Oh, okay.
So yes, nobody in an unoccupied derelict building at all. So we're all dealing with probably all in the houses, the homes that we're looking to work on. Right, I think I've stopped that now. So there you go, a bit of an idea panel. And we promised this would be a where to start. So I'm going to start with a question that came in from Hazel Ball earlier today, which I thought was a great one to get us started. Is there something that's best done first? Is there a preferred order to do things in? Where do you start? So I'm going to chuck that to Nick first of all.
Okay, I think I would probably start with air tightness, and that can be a really wide range of things, from chasing out the blindingly obvious drafts to sort of doing your research and finding out what air tightness in buildings really means, and then trying to make yourself a strategic plan for dealing with it. You're not suddenly going to be able to make a completely airtight home, and if you haven't sorted out your ventilation, you're going to have problems if you do. But actually dealing with air tightness before you start thwacking on insulation and so on, because otherwise you can have cold air moving between your insulation and the original fabric of the building. You can get air in the wrong places. So I think, yeah, realizing the importance of air tightness and trying to get on with dealing with it would be one of my first things.
And just to follow up from me, Nick, so, and is does air tightness mean drafts, or does it mean more than that?
Yeah, it's unintentional ventilation. So
okay.
Design out the unintentional, design in the intentional.
Great. Okay, I like that as a saying. Right, Florence, over to you.
Yeah, I mean, you could approach it in a couple of ways. I guess it depends. So I like to get something under my belt, so maybe do something that's relatively easy, like loft insulation, and then that gets you going. I say it's relatively easy, but I managed to fall down the ceiling, so so do be careful. And then if you are looking at air tightness, so there's the obvious sort of draft proofing things that you can do DIY, and then you can go a lot more into air tightness and sealing things up, as Nick is saying. Once that gets underway, you really need to start thinking about ventilation. So another way to think about it is, you know, how much disposable cash have you got at the moment? And maybe if you've got £5,000, you could just go for the ventilation system straight off, which is supplying fresh air, filtered fresh air to your livable spaces, and then extracting the vitiated air, the odd, the bad air through the kitchens and bathrooms, and you recover the heat that way. But that means you've got your controlled ventilation in the right places, whilst once you've done the air tightness bit.
I suppose what I was particularly thinking about is if you get your own hands dirty, as it were, then provided you can get a bit of a roadmap from somebody about where to look for the issues with air tightness, you can actually start poking holes in things and get in there and do things quite simply and cheaply. You make a big mess, mess, no doubt about it. But you can get in there and do it quite simply and cheaply if you haven't got, sometime you've got to do the ventilation. I appreciate that, but okay,
I'm going to cut you off, Nick. So there's a couple of items: air tightness, ventilations, a couple of things I think we'll probably come back to, which for those of us who know very little are already sound a little bit complicated. But Eliot, so for you, what's the preferred order to do things in? Where do you start? What would you say?
The motto of the Energy Saving Trust is build tight, ventilate right. So what Florence and Nick have said about making the building more airtight is correct, but only if it's correctly ventilated, because if you seal it up and you don't ventilate it properly, you make the thing worse than it is now. So I would say look at it holistically, think about ventilating it, but also sealing it as well, so you're controlling the flow of air through it. I would also say if your boiler is older than 2006, get rid of it immediately and put another one in, because there was a magnitude big leap in efficiency of boilers. At about 2006, they went to modulating boilers. So they went to about 90% efficient instead of 60% efficient. So as a quick, easy win, you can put a more modern boiler into the property. Even though that's gas and fossil fuel and everything else, there's a lot of second-hand ones out there that were replaced under the government grants. They took out good boilers and put other boilers in that are the same. There's a lot of boilers out there that are still 90% efficient. You can pick them up very cheaply. And if you go from 60 to 90% efficiency, you're saving a big chunk on your heating cost as well. So that, in terms of your emissions, that's the easy one. Your roof is one of the largest surface areas. So you're right, make sure the roof insulation is probably the first thing to tackle, because compared to insulating your walls, it's a lot less expensive and a lot less messy. If you've got solid walls, it can be quite a big job to insulate them, let's say. If you've got cavity walls, assume that the cavity insulation in them has failed by now, and that can be replaced with something better, because they only really last about 10 years. So if your property has got cavity walls, that's the second thing after your roof. Get rid of your letterboxes and your cat flaps, because they let an awful lot of heat out as well.
Okay.
Your easy wins.
We'll come, and we've certainly got a question about drafts and ventilation and fears about damp, etc. So we'll come back to that in a second. I'm going to ask you though, we hear this talk of fabric first as an approach. So what does that mean? So if you're thinking about where to start that question, what does fabric first mean, and how do you work out what it is that you need to do first in your building? Do you need an assessment? Do you need a thermal camera? Do you know, how do you go about that? Good one. Florence, yeah. Chuck to you first.
Yeah, so fabric first is definitely where I would start, but so you can get a retrofit assessment done, so somebody will come around to your house and probably with a thermal imaging camera, so it helps to visualize where the heat losses are. You can only really do that on a cold day though, so it depends when you're getting started. So but essentially what your heating system is trying to do is put in the heat that is getting lost through your walls, your heat loss areas, which are your walls, your roof, your windows, your floors, and also your ventilation system. So, so what we're trying to do is reduce the size of that heat input, and then the hours that you use that heat input. So, fabric first is essentially just reducing the size of your heat system.
Great. Okay, I can see the others you nodding away, so forgive me if I come back to you two, and we can move on. So a question that had come in from Alison Horsfield about insulation. So I'm in a 4-bed semi-detached house built in the late 60s. What is the best cavity wall insulation? She says, I've heard that it can lead to water channeling to the inner wall. So I think this is what we've all heard about, people having cavity wall insulation put in and then having mold, I think often, isn't it, on the interior wall. Nick, I know you've had experience of this. I mean, not personally.
No, right, okay. Well, the one I'd probably be least likely to use would be mineral wool, because potentially that can suck. But an awful lot of it depends on whether you are doing cavity wall insulation when you should be doing cavity wall insulation, or doing it when you shouldn't. A lot of the scare stories that we hear on the radio and see in the newspapers are about situations where cavity wall insulation has been done, for example, on houses that are on the seafront receiving seawater horizontally, and the Cavity Insulation Guarantee Association, which is the trade body, they have a series of preconditions, where they say basically, if there's crud in the cavity, you don't fill it unless you can clear the crud. If the property is poorly maintained so that the outer skin might get soaked, you don't fill it unless you've dealt with that particular bit. If there are snots of mortar on the cavity wall ties which might trap moisture across, you don't do it. There's all sorts of preconditions, and if you try and get those right, and then use, in my view, generally to minimize risks, something which doesn't suck, then you're onto a good beginning.
And when you say suck, you don't mean as in suck, you mean
I mean act like a sponge.
You're an American teenager.
Anything to add to that, Florence or Eliot?
Yeah, just to answer your previous question, fabric first means focusing on reducing the amount of energy the building needs rather than throwing solar panels and heat pumps into it, to a basket case.
Yeah.
So it's about demand reduction rather than all the generation side.
Well, and
so it's the opposite of what the government tend to support. But your cavity wall question, a 1960s house probably have about 75mm cavity. So what happened about 10, 20 years ago is in order to try and help people to reduce their carbon footprint, namely the energy companies, a lot of people had the cavities filled with mineral wool because it was about 400 quid. It was a cheap as chips measure, but that blown fibre isn't designed to go into a narrow cavity, which is 75mm is. What happens is they drill a hole pattern up to about chest high, because any higher than that, the drill gets heavy and they don't bother with that bit. And then they inject this blowed fibres into their cavity walls. It's like blowing candy floss into the wall. Because the wall's only narrow, it hits the back of the other face of the brick, and you get a clump of insulation behind the hole. And then they move about a metre to the left or the right, they do another hole, they blow another clump of insulation in there. And it's so like... If you see it with a thermal imaging camera, it's like looking at a Teletubby, it's just spots everywhere. So what happens is, after a period of time, that mineral wool is deteriorating like it does in your loft. Meanwhile, the top of the cavity is open to the roof space. So you get dust settling in the cavity from above. And that's weighing down on that mineral wool that's already deteriorating, and it's only in clumpy patches anyway. So after about 10 years, it's all slipped down to the bottom of the cavity and turned into a soggy mush. So it's not doing anything. It's there. It's insulation in name only. So I've surveyed 250 houses for a local housing association, and every single one was failed, and it was all damp. Oh. So this is what I mean. You can't assume that because you've had your cavities filled, your walls are insulated. It's safe to assume the opposite.
So what do you do, Eliot? Where do you start then?
There are a few companies now, and the number is growing. And what they do is they extract that rubbish out of the cavity. So they'll take a brick out. They'll find the damp-proof course at the bottom of the wall. And they'll take a brick out maybe every 5 along the base of the property. They'll put a hole pattern in. They'll blow compressed air in at the top, and they'll have a big vacuum cleaner at the bottom. And ultimately, they empty that rubbish out of the cavity. Now, what Nick's saying about the snots in there, which is cement, it's difficult to get that out. But, usually if your cavity's 3 inches wide, the snot doesn't generally bridge right across anyway. So the first thing to do is you remove that insulation from the cavity because it's more harm than good. Yeah. You put the bricks back in, seal up the wall, and then you refill it with a product that isn't going to fail like that. Then it's going to cost infinitely more than the 400 quid for your wall insulation, because you pay more than that for a jacket. So we're talking about insulating the walls of your house here. It's not a 400 quid project. It's a £10,000 project. But the modern products are injected liquid, and they expand in the cavity and glue the two things together, and they give you the air tightness as well.
So I was going to ask about products, because we had a follow-up question about being concerned about using synthetic products. Is there any natural insulation you can use in a cavity? But I think also people are interested in what are the pros and cons of synthetic versus natural products for insulation generally. So just on the cavity, what are the options? Is there a list of options, Nick?
Well, mineral wool we've talked about. Bonded polystyrene beads nowadays, that will probably be graphite enhanced expanded polystyrene, which has a lower thermal conductivity, therefore better performance than the old blown white beads. And Eliot will tell you more about 2-part polyurethane foam. Probably.
Almost certainly.
So
the modern products, they inject this. It's like, think of it as liquid kingspan. They mix an A and B side, and they do a hole pattern on your wall, and they start at the bottom, and they inject in a liquid, and after about 5 minutes, it's risen up like a cake, and then it sets hard like a piece of kingspan, but it fills every square millimetre of space in the cavity. And then there's another hole pattern, slightly higher than that. They inject that in, and that rises up like a cake. And eventually, you make your way all the way to the ridge of the building. And what you've effectively done is you've poured liquid kingspan into the cavity wall and completely and utterly sealed it. And that is, there's no gaps in it. There's no thermal bypass around it. The product is vapor open so that the wall can still breathe from the inside to the outside in the winter and from the outside to the inside in the summer. It's got to be capable of drying that wall. Otherwise, you can't have any kind of barrier in there. Otherwise, it can't dry. So the product does remain vapor open, but it's like pouring kingspan into your cavity wall.
Thank you. Any natural products that are an option?
I'm not aware of any that have third-party certification. I don't want to get into too much detail, but basically, if you want to get building regs approval for any insulation measure you do in your house, you've got to be able to prove to the building control officer that it actually does what it says on the tin. And you usually prove that by the fact that it's got a certificate from the British Board of Agreement or BRE Global or one of many third-party testing houses that basically put them through loads of laboratory tests to say, is it fireproof? What thermal conductivity has it got? Is it resistant to insects and whatever? And I certainly can't think of any natural material that's got a BBA certificate for cavities, and I can't think of anything which I'd be 100% comfortable in using because of the potential moisture risks involved, etc. I mean, there are things like Laker light expanded clay aggregate, vermiculite, but all of those can be adversely affected by moisture. So I think the fact that, as far as I know, feel free to prove me wrong because I'm not an expert in cavity wall insulation. As far as I know, there's no natural materials with a third-party certification. There may be a good reason for that.
Okay, thank you. And can I just more generally on natural versus synthetic, Florence, what the pros and cons?
Yeah, so I guess my my base position is to try and work with nature as much as possible. And I know that the cavity does cause particular issues, and therefore that's where I would sort of draw, you know, I'd say actually in this case I would go for polyurethane foam or the EPS beads, which we're going to go for with the grey EPS in the cavity. But in general, I would try and work with natural materials as much as possible. They have breathability. We know where they come from. We know what happens to them at the end of their life. And they're just so much nicer to work with. So, you know, if you're sort of talking about a whole approach to building and building materials, and, you know, natural materials does include rock wool and mineral wools and things like that. They are natural products. They just have a bit more embodied energy, embodied carbon to them. And actually, embodied carbon is becoming more of an issue, certainly in new builds. If you look at the lifetime of a building, the embodied carbon, so the carbon that it takes to construct the materials, make the materials, construct the building, that actually becomes more important versus what can be more important than the operational over its lifetime. Or it can be, you know, the similar order of magnitude. And in retrofits, you know, that argument is slightly less of an argument, but there is always an end of life aspect to a material. So, you know, my perspective, I like to know where it's going to go, and then.
Okay, thank you. And I know there's quite a big conversation that could be had about natural versus synthetic. We perhaps won't spend much longer on that. But Tracy, are there any questions around insulation types or materials that we could throw in here before?
Yeah, there's quite a few come in. There's some themes that have come in. So there's some questions around ventilation. So ventilation is necessary for health and avoidance of condensation. So we've had a couple of questions around that and confusion around that. So there's a question here about being confused about air tightness versus wanting and needing ventilation. Okay. And then there was another one around what happens if you create a well-insulated airtight building when you don't ventilate it? If you just have to install an MVHR system.
Okay, so, right. So that, yeah, that's good.
We have those three, and then we can move on to the next.
Lovely. Yeah, and actually, there's, sorry, I'm cutting across you there. And a few of the questions we'd already had in, and maybe this one would be a good one for you guys to respond to, from Shelley Metcalf. She's got a 1929 house, is prone to condensation and mould. We had to put trickle vents into our double glazing to reduce the problem. My builder brother-in-law says old houses were designed to breathe. So I'm worried that if I fully insulate or draft proof the loft hatch, the front door, etc., we'll get unmanageable condensation. So that's speaking to exactly what you've been talking about. So what should she do? Where do you start? How do we deal with that? Or what looks like a contradiction between trying to make it airtight and to ventilate it. Nick, you're nodding furiously.
Yeah. Can I just say that when energy geeks talk about breathability, they are talking about water vapor permeability. They're not talking about the ability of air to get particularly rather unfettered into the building. So it's often a misunderstanding. I years ago, I did a series of talks in the Peak District National Park, and it was partly funded by the Peak District National Park, and one of their people looked at my proposed order for the day's training, and in the afternoon it started off with air tightness in refurbishment, and they were absolutely horrified. They said, you can't make refurbishments airtight, they're designed to breathe. No, they are designed to be water vapor permeable. If they're designed to be water vapor permeable, it's important to keep that permeability. But something we said earlier on, design out the unintentional ventilation equals drafts, and design in the intentional, which could be mechanical ventilation with heat recovery. It could be some other form of mechanical ventilation, even without heat recovery. It depends whether you have the possibility of getting in all the ductwork you need and so on. But they're not mutually exclusive. They can work together.
So Florence, I'm going to ask you, what is a mechanical vent heat recovery? I always get the words in the wrong order. What is it? What does it look like?
What does it look like? It looks like a box, a bit like your combi boiler at the moment in size terms. But instead of moving water, it moves air. So you've got ducts coming off it, either that way or that way. You've got an intake, which takes fresh air from outside, and you've got an exhaust, which exhausts the air. You've got fans inside there with filters and a heat exchanger. And what you're trying to do is get this fresh filtered air to your rooms, the ones that generally sort of dry, livable spaces like your living rooms and your bedrooms, because actually we need air to breathe. It's not just the building that needs breathing. We need air to breathe. And then because kitchens and bathrooms generate moisture, that's where your sort of condensation and mold, the sources of moisture for condensation and mold occur. You try and extract them directly from those spaces. So you're bringing fresh air in, extracting moist laden air from your kitchens and bathrooms. But that air that you brought in, normally you would get from windows or doors or leaky frames or whatever it is. And that air needs to get to room temperature. So that represents some heat energy that you've put in. If you have room air temperature that you're extracting from kitchens and bathrooms, you can actually take that heat back into the incoming stream. So the air from outside, which is cold, you exchange the heat, and actually the air that you'll bring into the room is nearer to room temperature. So it's a lot more comfortable.
You need a hand, Florence. You think we both know what my day job is.
What was that? Sorry, am I down a hole?
We need a hand with the MVHR description.
I think a diagram might be useful. So yeah, so it's bringing air in, getting it out, but before you can take it out, you exchange the heat.
Yeah. So
MVHR is a heat recovery system, but all I would say about the ventilation is your house is designed to correctly ventilate a house. You need to change all the air inside that house every 2.5 hours. That's the regulation. There's 2 ways of doing that. You either have vents on all of your windows and extractor fans in your bathrooms and your kitchen and any other wet area, sized so that they're capable of replacing the volume of the air in that building every 2.5 hours. So on a typical family home, you would have trickle vents on every single window in the property, and you'd probably have 3 continually running fans. That's the only way you're going to get the mandatory amount of air movement through that house. So that's your traditional ventilation. It's extract only. It doesn't work if you haven't got trickle vents. So the air path comes through the window vents, goes through your bedroom, down the hallway and out to the bathroom wall. And every 2.5 hours, you've got to replace all of the air inside that box. So once you're ventilating it, then you can seal the box up. So you're controlling the path of air through it. What MVHR is, mechanical ventilation with heat recovery, it's designed to change the air every 2.5 hours, but not lose the heat that's in the air. So instead of having the vents on the windows, it supplies air to the bedrooms and the living rooms, and it extracts the same volume of air from the bathrooms and the kitchens.
So thank you. I think between you, you've explained that really well. But I don't think I know anybody with a mechanical ventilation with heat recovery system. It sounds like it's a big job to put into your house. It sounds like an expensive job. Is that really the only way to counteract sealing up the drafts?
No, you can put the trickle vents on your windows, and you can have extractor fans.
Okay.
That's giving you controlled ventilation. Opening windows doesn't work, and neither does having extractor fans without vents on the windows. That doesn't work either.
So going to this system, so putting in something like that into a house while you're living in it, what kind of cost are we talking about? What kind of disruption? I know that's a bit of an open-ended question, but just a rough idea.
Lots and lots. Lots of cost and lots of disruption. But it's fundamental for an ultra-low energy house. If you're on an eco house, a passive house or anything like a passive house, it's the fundamental component of that type of property. It's just difficult to retrofit it quickly and easily and cheaply, which is why I generally work on refurbs and new builds.
It does depend on how compact your house is, because the ductwork could just literally be poking into each room from the corridor.
Yeah, there's
have to be extensive, and so it could cost about £5,000, £7,000, maybe up to £10,000, depending on how extensive your system is. So it's that order of magnitude, but it really does depend on how far you're going to go with your retrofit. I mean, for me, if you're going to go and pay for triple glazed timber frame windows, and then you're going to stick a hole through basically what a trickle vent is, personally I think that's a big waste, or a wasted opportunity anyway. So yeah, I think
it would help to define what a retrofit is, because there's a sliding scale from I'm driving a mini digger in the kitchen and scooping out a foot of the floor all the way through my house. That's one end. That's a deep retrofit. And the other end is I'm putting another 150 millimeters of wool in the loft, and I'm going to maybe make sure the bathroom fans are working, possibly put a couple of trickle vents in, and otherwise draft strip everything. That's the easy end of the business. But there are people who will do both of those two ends. You start with the easy things, but 34 years later, you end up with MVHR in your house, don't you, Nick?
Well, I think at the beginning, Lynn asked, what was one thing we would do, and actually, I missed a trick, because we all came in with physical things we would do. But the first thing I would do ideally is make a plan of what I want to do to the whole house. And okay, my plan has changed a bit over the 34 years, but I do have a whole house plan. I've never been able to empty the house and have enough time to do all the work at once. But if you have a whole house plan, you've got a list you can tick off and say, right, I've done 5%, hurrah. You know, and just doing that plan at the outset will show you the enormity of the task, but it'll show you the elements of the task as well. And, you know, for example, should I chase air tightness first, or should I put the ventilation system in first? Well, if you chase the air tightness and you're prepared to have temporary ventilation solutions, you might then put off the MVHR till later. You can start making informed decisions if you have a plan that you can read off.
Yeah.
The kind of people that I work for are typically around the age of 60, give or take. They've decided that this is their forever home. What they do is they move out of it, and they commit a significant amount of money to that property, more than a kitchen and a bathroom put together. And they'll move out of it for a period of time. They'll insulate all the walls, they'll retrofit MVHR, they'll redecorate it, they'll put a new kitchen and a bathroom in, and they'll invest a significant amount of money in what is going to be their forever home, because the return on that investment is better than leaving it in the bank. And they've got a comfortable, warm, cozy house to live in for the rest of their days. And it's sometimes you've just got to smash a few eggs to bake a cake. So there's a lot of people in that category.
Eliot, I'm going to cut across, because there will be lots of people who are not in the position to do that.
I know.
So we'll stick to, but I think you've got some suggestions, and maybe the others are, about what are the unintentional airflows that you can stop or tackle without necessarily putting a mechanical ventilation system in. Are there obvious things that we should be, you know, that we might not have thought of?
You can put positive pressure ventilation in the loft and have a new extractor fan in the bathroom. That'll give you air movement without having to have you know, a fully ducted system put in. But the reason that no one even talks about ventilation and hasn't done is because on its own it doesn't save carbon. That means there's never been any funding for it. They only fund things that save carbon through the energy company obligation. So that means that the energy company puts money into a pot, and then they go around and they seal everyone's house up with cheap cavity insulation, because on paper that ticks the box. And all they're doing is creating a problem. But because the ventilation doesn't save carbon on its own, that never gets funding, so it never gets put in. You end up creating sealed houses, like the lady said, with no ventilation in there. So yeah, that's why no one talks about ventilation. It's like a dirty word. But so
okay, well, you've certainly given us a good introduction to what it means. I'm not sure we'll have answered everybody's questions, but I'm going to move on to, we'll come back to Tracy in a minute, but there's a couple of other questions that we had in before about wooden floors and about drafts and insulating under suspended wooden floors. So here's a question from Sarah Miles. We've got a 150-year-old terraced house with a cellar under the hall and the front room. A draft comes up through the floorboards. We can sometimes see the carpet move, but we've been told that if we insulate between the joists, this could lead to them rotting. There's no damp at the moment. The cellar has one small window below pavement level, which is always open. No ventilation bricks anywhere else. What can they do? Nick?
Right. Ideally, if you are going to, well, underneath the suspended timber floor anyway, ideally there should be cross ventilation. I generally refer to it as a howling gale. But the important thing is that the howling gale is isolated so that it doesn't lift up the carpets. So ideally there wants to be some insulation in there, and there wants underneath that insulation to be a wind type membrane, so that howling gale can go through, keep timbers healthy, but not blow your carpets up. However, the problem is that the house described has a cellar under the front room. I'm kind of assuming that, like a lot of other terraced houses, it might have a solid floor under the rear room. That makes it really difficult to get good cross ventilation. And I have come across lots and lots and lots of problems. For a long time, I didn't come across many problems, but I've come across lots of problems over the years with underfloor insulation where it's been put in, because when you put the insulation in to warm up the room above, you're cooling down the floor structure, you're cooling down the joist ends, you're cooling down the bottom of the joist, you're increasing the risk of condensation on the bottom of the joists, in the joist pockets where the joists disappear into the walls and sit on the walls. And in the same way as we like to have a howling gale in our loft spaces in order to purge them of warm, moist air, we need to do the same in our underfloors. And the problem is, even if you have a passage house and you're able to get a duct through into the passage, you won't always be ventilating. You might have 2 air bricks in the front and an air brick in the passage. You'll probably be ventilating a triangle of about half of that floor rather than the whole space. It's difficult to get full purging if you haven't got nice diagonal airflow throughout a rectangular structure.
Yeah. Eliot or Florence, do you want to add anything to that?
Yeah, suspended ground floor insulation, you can apply insulation between the rafters from underneath if there's a crawl space, as long as you don't encapsulate the bottom of the rafters. So as long as the bottom of the rafter is exposed to the ventilated void.
Can I say joist?
Did you say joist?
Can I say joist?
Yeah, what did I say? Oh, rafter. What did I'm talking about roofs again. Yeah, so you've got a suspended ground floor, the joists go across. As long as the bottom of that joist is visible to the is exposed to the ventilated void that's below it, they shouldn't sweat and rot, including where they hang onto the walls either. So you can insulate between the joists on the ground floor if you can get underneath it. Sometimes
if you haven't got satisfactory cross ventilation, you probably will get moisture issues. I've seen bucket loads of examples.
Yeah, so you have air bricks to allow the void below that suspended floor to breathe, and that also allows the bottom of your joist to breathe as well.
But what I was saying just now is if you have air bricks allowing air in at the front of the property, but at the rear of the property is a solid floor, there's no exit for that air. Air is fundamentally lazy. It will come in one air brick and it will go out the other one. If it can't go across, it won't purge that space.
Yeah, and I think that's the case in that example. So what's the answer is to, in that case, Nick, is to actually not do anything?
It's difficult. I hate ever advising people not to insulate, but you can take a risk management approach. You can basically, before you think of doing anything, you can look at what ventilation you have got. You can test the moisture content of your joist ends with a wood moisture meter. Basically, if you've got 18 to 20% moisture content, you're probably okay. If you've got much higher than that, you have to start looking at why you've got that. Maybe lots of crud has fallen down around the joist end and it's wicking moisture from the outside of the wall through to the joist end. So clear out all the joist pockets as much as possible, get them as dry as you possibly can. And I would basically say if you've got a void without proper cross ventilation, if you decide to insulate it, then keep a watching brief on it. And if it goes wrong, be prepared to take it out. I know that doesn't sound great, but I think you have to be realistic about it. Or
you can add cross ventilation if you haven't already got it.
But if that means well, I know you like driving a digger in the kitchen, but you know, if that genuinely involves having to take up the concrete floor in the kitchen and go through, a lot of people just won't do that.
No, well, that's the most difficult of all retrofit jobs, is solid floor insulation.
Yeah, I mean, if you do have a solid floor in the back room, and you're casting a new solid floor because you want to insulate it, you could actually take 200 or 300 mil ducts through under that floor to the back of the house, so that you have your cross ventilation. you've got the in and you've got the out. You've got the in at the front, you've got the out via 3 ducts running under your kitchen floor. Sorted.
Okay, thank you. Tracy, do you want to throw in any questions?
Yeah, we've had also some questions about the choice of insulation for attics. So is spray insulation a good choice for attics? Are there any issues for surveyor evaluations of property when using spray insulation? And then we've had just a more general question about what insulation you would recommend for lofts.
Okay, should we do that then? Attics and lofts insulation, and there was also a previous. Oh, actually, no. Let's stick with those. What, Florence? Do you want to kick off?
Yeah. So if I talk first about insulating the floor of the loft, we've gone for wood fibre between the joists, and it's sort of semi-rigid, and it just sort of friction fits between the joists, which is quite neat and easy to handle. And then on top of that, we've got hemp fleece, which is also really nice to work with. It's a little more rigid than we thought it would be. I thought it would be like a roll, so it was a bit more tricky to install and also get all the panel, what do you call them, bats all the bats fitting between the spaces that you've got, or across the joists and things like that. Yeah, nice material, smells lovely. And then we have boarded an area of the loft, so we had stilts which are 300 mil tall, and then we've got some nice OSB boards on top of that, so we can store stuff in the loft.
OSB, oriented strand board.
Yes.
Poor person's plywood.
Yes.
Formaldehyde magnet.
Oh, you can get low formaldehyde.
All right.
Yeah,
Did someone say spray foam?
Someone did, Eliot. I think that might be your cue.
So if it's a loft conversion, you can put an open cell spray foam between the rafters. You go underneath the rafters with a sheet of Kingspan or Celotex. You hold that in place with a batten, and then you put a plasterboard onto that. And provided you're not spraying it onto the underside of the tiles or onto a non-breathable underlay like black bitumen felt, then that will pass the condensation risk analysis, which means you get a guarantee with it. If you've got a black bitumen felt, or you've got no underlay at all under the roof, you have to put a cardboard cassette in between the rafters and spray onto that, so that the foam doesn't touch the tiles or the non-breathable felt. There's a certain build-up for doing a roof insulation. If you let your builder put Kingspan between the rafters, it's going to be suffering from something called thermal bypass, isn't it, Nick? Where the heat and the noise just bypasses the sides of the insulation, because it fits in there like, well, it doesn't fit in there. There's gaps on either side of it. The only thing that's doing any work is the insulation that's below the rafters.
It can be fitted very, very loosely. It can be fitted very tightly. I've done a lot of attic refits, and in general, particularly if you're talking about an older roof, you've probably only got 75 mil rafters. You may have to leave a gap, an air gap, a ventilation gap of between 25 and 50 mil. So you're probably only putting 25 mil of insulation between the rafters, and to meet the insulation value set out in the building regs, you need another 100 mil underneath. So the majority of that is in an unbroken, carefully taped line underneath the rafters in any case. But main thing is
with any rafter level insulation is to check that whoever puts it in can deliver you a condensation risk analysis. In other words, they can model it and tell you that there's not going to be any interstitial condensation problems with it. If you just get a builder to put it in there and there's no modelling done on that, it means you've got no guarantee. So if it all goes pear-shaped, you're on your own.
So anything else to add about roof insulation, Nick?
Well, like Florence, I quite like natural solutions, but and there are some people that certainly said to me in the past, you know, you shouldn't be teaching eco refurbishment and talk about using synthetic materials. But sometimes if you've got, you know, an existing Victorian attic, for example, so it's not an attic, it's not a loft conversion, it was an attic room from the day it was built in 1880. But it's never had any insulation in. So you want to insulate it now. You may find that if you wanted to use natural materials to meet the standards set out in the building regulations, you'd probably need about 250 mil, 10 inches of insulation. That might mean that you crack your head when you're not even at the top of the stairs. That sort of practicality. So sometimes I think you do have to be pragmatic and say, right, well, maybe I'll use a synthetic insulation. And one of the things, in the end, the most important person in a retrofit is the occupier, and it's important that you don't advise them to do stuff that they're not happy with. So,
yeah, sure.
Sorry.
I'm sorry.
In the end, you know, it's important that they're happy with it. So what I sometimes say to people is well, okay, yes, you're using petrochemicals, as you know, in the polyisocyanates at Kingspan Celotex type insulation, you're using petrochemicals, but you're using petrochemicals in a capital expenditure in order to reduce your use of petrochemicals as natural gas in your boiler year on year on year on year. So, you know, if that kind of helps you to justify it, then go for it.
Okay.
I'm all for I'm all for non-synthetic materials, but at the end of the day, if synthetic materials work better and reduce your heat demand for the next 50 years and don't deteriorate over their life, it's a responsible use of a petrochemical, as far as I'm concerned.
Right, I think there's quite a bit to discuss about, I think, between the difference between synthetic and natural, and whether or not natural materials do deteriorate, and whether it's to do with the conditions they're used in, which I'm going to stop now because there's a couple of the topics to get onto. I'm sorry that might be frustrating for people who want to pursue that conversation a bit more. I think there's a couple of other sort of key points to cover, and Tracy might, I know there's loads of questions coming in, I'm sorry we're not going to cover everything, but I wanted to move on to the heat pumps, boilers and heat pumps. But before that, we haven't really talked about external and internal wall insulation, and at what point those are things that might be considered for a property. I mean, that's quite big jobs, and I think all of you have talked about doing it on your own homes, but you just give us an indication of what would be, how would one know that that would be something that needed to be done in your house, that it's, you know, it's not about changing the windows, it's actually about the walls of the house. Let's start with you, Florence.
Yeah, so we've got a very bog standard cavity 1970s wall. So I know that I can fill that cavity if I do, you know, in a proper way, fill the cavity and then stick on external insulation, and I'll get the best performance out of that wall by doing that. And it also gets rid of thermal bridging, which is the cold bridging, you know, short circuiting of heat through certain structural elements, because I'm wrapping my house from the outside. But you can't do that, for example, if and correct me if I'm wrong, Nick, but I don't think you can do that with a solid masonry wall necessarily, or if you've got conservation constraints on the facade of your building. So then you'd have to go to internal wall insulation. And there's a problem, a little bit of a problem there in terms of vapor permeability rather than breathability. So we tend to sort of limit the amount that we put on an internal wall. So you can't really push those that performance as far as you would with the external wall insulation.
Nick, do you want to come in?
Can I jump in? Yeah, I mean, So basically, to say what Florence, to pick up on what Florence said, no reason why you shouldn't do it on a solid wall as well. External insulation, it's the best way of doing it. To wrap up your building in a nice, snug, waterproof and warm overcoat is the best way to do it. To a lot of people, for example, because of aesthetic constraints, you know, the conservation people, planners won't let you do external insulation, whatever it may be. So you're going to do it internally. It's important to know that when you warm up the room, you're cooling down the wall. So every wall has a dew point. It has a point at which water vapor will turn into liquid, and that's normally just about on the outside of the wall. Might be a little way into the wall, but it can find its way outside and waft away into the atmosphere. Whoopee, happy. When you put insulation on the inside, you bring the dew point in, and there is a risk then that you might bring it right into the internal surface of the wall. So you might get condensation on your wall behind the insulation. You might get condensation affecting the joist ends, the timber lintels that are over your old Victorian windows and so on. And you can have a bit of a catastrophe going off there. The typical way with synthetic materials and some natural materials as well is to use what they call a vapor control layer, which is typically a sheet of foil or a sheet of polythene. The idea being that if you keep all the water vapor out of the wall, you won't have what they call an interstitial condensation problem occurring within the layers of the sandwich of the wall, and therefore it won't be an issue. That's fine as long as your vapor control layer is absolutely perfect when it's done and remains perfect throughout the whole life of the building, so that every plumber who puts a new toilet in for you knows that they've got to tape up that vapor control layer around the soil pipe. Everyone who puts a new window in for you knows that they've got to tape the wall round to the window. I think I use quite a lot of rigid wood fiber insulation with a lime plaster. You still have to limit the thickness. You can't go to as low a U value, as high a thermal performance as you could do if you were insulating outside. But I use wood fiber because it doesn't rely on a vapor control layer. It just relies on being very, very dense and very moisture buffering. It's about 5 times more dense than Kingspan Celotex. And I reckon if you don't have a vapor control layer, you can't get it wrong.
And does that apply to internal and external?
No, external's a different kettle of fish.
Briefly about external.
Because you're wrapping the whole building up in insulation, and the insulation's on the correct side, as it were, on the outside, then the likelihood of interstitial condensation is minuscule, somewhere between minuscule and nil.
So does that suggest that if you have the option, external insulation would be preferable to internal?
Would be to me.
Yeah.
Okay, would you do this? You agree?
Yeah, the general idea with, if you've got solid walls, the short answer is they need to be insulated, because the solid wall is a very effective radiator. So you warm up the inside of the house and you just radiate it straight out. If you've got a solid wall, it's got to be insulated either inside or outside.
And which would be your preference, Eliot?
If you insulate the outside of the wall, then the actual wall itself acts like a thermal mass. So when you warm your air up to 21 degrees, eventually that heat travels into the wall, and that wall will retain that temperature. So that when your heating goes off, you've still got heat in the property because you've warmed up this enormous thermal mass. And your insulation's then on the outside like a cozy blanket, like Nick said. But if you're in a conservation area or you don't want to change the outside appearance of your property, you've got to do the inside of the wall. But you've got to do if it's a solid wall, you've got to do it at some point in either now or in the future. But if you've got a cavity wall, you must always fix the cavity first. You don't want to put external insulation and leave the cavity wall empty, because the cavity is going to have cold air whistling through it. So the exterior insulation is having very limited effect. You've always got to fix the cavity first, then then the rest of the insulation you need is better going on the outside of the wall if you can. And you'll find that the cost of the exterior insulation, because it improves the curbside appeal of the property, the cost of the exterior insulation generally will add the same amount of value to the property anyway. So it's a no-brainer if you've got the money to do it. However, if you're in a conservation area, you've got to do the inside of the wall.
But it's also sorry, there's also less disruption if you do it on the outside.
Oh God, yeah.
Whereas doing it on the inside, you have to move radiators. You need, it's a big job, and then your air tightness gets your air tightness layer is more difficult to determine the continuity throughout the house. So. Yeah.
Thank you. And we've got.
Just need to correct one thing that Nick said. He's talking about, he's correct in that you need a vapor control layer on the wall, because what you're trying to do is you're trying to control the passage of vapor, which is water in gas form, as it travels through the wall. So when you put your heating on in the winter and your house is at 22 degrees and it's 0 outside, the water vapor, which is the moisture that's in the air, is trying to pass through the wall from the inside to the outside of the property. So you to control the passage of that vapor, you put a barrier on there. So it's a vapor control layer. It controls the passage, but it still lets vapor through it, but at a particular sort of rate. If you put a visqueen on the inside of the wall, that's a vapor barrier. It's very different from a control layer.
Okay, I'm going to stop
barrier
this
in there, you can't breathe.
I think we're getting a bit too complicated for a lot of us, so I'll leave you to have that conversation afterwards. A couple of quick questions I can see here. If we can have some one-sentence answers. What's the best external insulation material?
The best depends. If you're prepared to have it thicker, then something like a mineral board, because it's a non-synthetic product. But
okay,
if you're limited, if you've got
Florence,
I'm putting wood fibre on the.
Nick.
I'm not using wood fibre because my back is too old and I couldn't lift the sheets up the scaffolding at the thickness I wanted. So I'm using graphite expanded polystyrene. Sorry?
Getting someone else to do it.
Yeah.
Okay, and one other question, which I'm not sure, there may be something in this that I'm not spotting, but it says, can you externally insulate on a semi-detached house? I'm not sure what the...
Yes.
Yes.
I think the reason for the question is because your house is going to be a lot fatter than next door. I was involved in one in Manchester, and the house that we did sticks out 225 mil, 9 inches more than next door. Consultation went on. The next door neighbour didn't mind. If you don't mind that your house looks slightly fatter than next door's house, it's not a problem. You may need to get planning permission. Do remember that. I've got to get planning permission for doing rendered external insulation on my brick built house, because it's permitted development if it's going to look roughly similar. So if you had a rendered house and you're going to put insulation and render on, you probably have permitted development, though don't take my word for it. But which means there's an implied planning permission already in place. But if you're going to change brick to render, you almost certainly need planning permission. That does vary from authority to authority. That's the case in Sheffield, and Florence wants to come in.
It's the case in Cheshire East as well.
Thanks, Florence.
Certainly if you're in a terraced or a conservation area.
Sorry?
If you're in a conservation area, you can pretty much forget it.
Okay.
No.
Can I stop? I'm going to stop you, sorry, because we haven't got much time, which is brilliant, isn't it? There's loads, but still, I feel like every answer leads to more questions. But I wanted to talk about boilers and heat pumps, because that's obviously where the government is encouraging us to look from next April. How do you judge whether or not there's enough insulation already been put into the fabric to get the smallest possible heat pump? You need a room for a hot water cylinder, don't you? And what about your radiators? Is there any implication for those? So we've got just a couple of specific questions here from Caroline Gibbs. We have a 4-bedroom detached house built about 30 years ago. We are considering a ground source heat pump to replace the gas boiler. Our garden is not large. I've heard that it's possible to put pipe work vertically. Have you got any information on this? And I'm going to give you another question to give you an idea of the sort of questions people are asking. We live in a 1930s 30s style semi-detached house. we have cavity wall insulation and decent loft insulation. What would be involved for us to install a heat pump? And someone else concerned about, in a 1970s house, they've already put in double glazing, they've done cavity wall insulation. They want to change their combi boiler, but most radiators are connected with a micro bore copper pipe with 8 millimeters. Do they have to widen, make the pipes bigger? So lots of sort of technical, so there's some general, is it ground source, is it air source? How do we know we're ready to have one? And some practicalities. So I'm going to start with Nick.
Right, 10 years or more ago, I'd have probably been pointing you towards ground source rather than air source, because the Energy Saving Trust did some field trials and showed some pretty poor coefficients of performance. That's kilowatt hours of heat out for each kilowatt hour of electricity to run the pump. And they were particularly bad with air source. They have got better and better. And just to go on that question about we haven't got a big garden, most people, when they come to me saying, can I have a ground source heat pump? I've got quite a big garden. Have a quick look at the garden and say, yeah, okay, but you might want to ask your neighbours each side if you can borrow a bit of their garden as well. Because when you have a trench field, it's got to be pretty jolly big. I would just say that over 10 years ago, I know of a scheme with a heat pump which involved three boreholes, and it cost 11,000 quid just for the boreholes.
Okay, so are we talking air source heat pumps really then?
That's the government's default.
Sorry.
Well, Eliot?
Yeah, the government's got this crazy idea that we need 600,000 air source heat pumps a year to bring us off to reduce our carbon. But what they don't realise is you can't just pop an air source heat pump in most houses, because it's just going to be a big disappointment. The water it produces has a flow rate of about 40-45 degrees, whereas your gas boilers, the flow rate is 65 degrees or more usually. So it's like turning your gas boiler down by a third in the middle of the winter and hoping that your house is going to be warm. And then secondly, the surface area, because the water temperature is lower, you need more surface area to deliver the heat. That means all your radiators need to be replaced. The lady with the 8 millimeter or the micro bore pipes onto the radiator, that's too small to allow the flow of water. So all that pipe work's got, it's a new central heating system. So what I predict is going to happen in about 5 years is going to be an enormous industry created with heat pumps, and that is ambulance chasers saying, will you missold a heat pump? Because there's going to be a lot of disappointed people who just put an air source heat pump into a regular house. It's not going to work. It's going to cost more to run than they're currently paying, and it's going to cost probably 15 grand to put the thing in. And I know that they're talking about there's a £5,000 grant available, but currently there's a renewable heat incentive that's worth about double that amount. So they're basically bragging about the grant, but not telling you that they're taking away the current scheme, which is worth double the amount.
Okay, let's
tell you what you've got to do to your house to make the heat pump viable.
Yeah. So Florence, do you want to pick up on that? What do you think?
Sure.
How do you switch from, if you've got a gas boiler that needs replacing, what can you do?
So I agree with Nick that 10 years ago I would have gone for the ground source heat pump, just in terms of the technology and the efficiencies that you get out, and that's basically because it's easier to get the efficiency without much thought. These days you can put an air source heat pump in, get similar performance out, but it does need really good matched design of the system and the flow rates and the temperatures. So air source heat pumps, in terms of cost effectiveness, are definitely much more viable for most people. But if you've got a very, very large house, then ground source would probably make sense. Also, if you don't have an air source heat pump, needs an external piece of kit. So if you don't have that space, or your neighbours object to it or whatever, you're not going to be able to do that. And I agree with Eliot, you can't just swap out a boiler for an air source heat pump and get this, and get what you're used to. or you could, but for your radiators, as he also said, and it would be quite costly. And the grant at the moment is high, but it's paid over 7 years. So if you've not got the cash up front, you can't actually make that step. So there's all sorts of variables. Ideally, you would go for the fabric first approach, because what that means is you can get the demand and therefore the size of the heat pump right down. So instead of a 15 kilowatt heat pump, you end up with a 4 or 5 kilowatt heat pump. And that is roughly the difference in cost as well. You know, instead of 15 grand for a heat pump, you're paying 4 or 5 grand for a heat pump. But the stuff that you put in your walls and your windows will last a lot longer than the heat pump. So, you know, you've just got to make that that call on that basis.
Even if you do reduce the energy demand by working on the fabric, when you're putting in that heat pump, you would still need to consider whether or not your radiators are adequate. So you still got additional costs and work, other than it's not a swapping out.
So at that point, if you are doing that level of retrofit, so you're getting your demand down to about a third or a quarter, then it starts to make sense. Your radiators are about that size at those lower temperatures that make it efficient. So these are all sort of win-wins of looking at the fabric first. And then your bills will also be a lot more commensurate, because obviously electricity costs about 4 times gas. So if you didn't do that, even though you'd be getting, you wouldn't be consuming as much electricity as your heat demand, because you're getting coefficients of performance, which means that you get 2 or 3 times the amount of heat out for the amount of electricity in. In order to get those higher COPs that we call, the performance, you have to run it efficiently. So, and not a lot of people know how to do that, and they might not be told how to do that. So they might be running it at high temperature, running it at certain times.
Right.
So they're not getting those coefficients of performance. So their electricity bills will inevitably be far higher than their gas bills are currently. So there will be lots of disappointed people unless they accompany the sort of heat pump strategy with retrofit, fabric retrofits, and education.
I saw an article in a newspaper recently. It said, we've spent tens of thousands of pounds on our heat pump and it hasn't saved us any money in running costs.
Yeah.
I would not expect, if I am finally able to put a heat pump in this house, I would not expect any reduction in my running costs. The reductions in my running costs will come from the insulation and airtightness work I've done. Even if I manage to get the holy grail of a coefficient of performance of 4, so 4 units of heat out for each kilowatt hour of energy to run the pump, which is not very usual with air source heat pumps. I know one person that manages it, but even if I manage that, since my electricity costs about 4 times as much as gas, then if I'm lucky, my heating bills are not going to go up with a heat pump. They are highly unlikely to go down. They'll go down as a result of the insulation that I do along with the heat pump, not because I'm switching to a heat pump.
Thank you. And I mean, I know there are some concerns about noise from source heat pumps as well, and having to have somewhere physical to put them on the outside of the house. But for those people who, especially if you're in a small terrace house, and as Mac has lots of, who are not able to do that. So if you decide, and for the reasons you've said, if we decide, okay, I'm not going to have a heat pump, when the gas boiler is coming to the end of its life or is very inefficient, what do you do? What's the alternative? Electric boiler?
Heat pump is an electric boiler. It's supposedly more
efficient.
efficient.
I wouldn't go for an electric boiler where you heat the water electrically. I mean, that does make sense for hot water, out of your tap, but not for your heating. it's a very inefficient way of delivering heat. But what you could do is have direct electric radiators. That will cost quite a bit to run, unless you do, if you can't get rid of your boiler, absolutely look at the fabric and get those, even if it's incrementally, you switch to triple glazing, get your ventilation sorted, get your insulation in, and then you can actually run direct electric relatively cost effectively, and then you can put solar panels on your roof to try and, try over the year, try to mitigate that decision, as it were.
Don't get too hung up on solar panels as being able to help defray the cost of running a heat pump, because it's when you most need the heat pump is when you're getting least from your solar panels. There's very few days in a year when your solar panels will produce absolutely nothing, but there will be lots of days in the year when they produce quite little. And you can't help the way our seasons work. You can't help that the time when you most need electricity to run your heat pump or your electric radiators or whatever is the time when there's least sun around for the shortest time. And you'd need an enormous array to give you the amount of electricity in the winter to help run the heat pump, and then you'd have far too much electricity in the summer. You wouldn't know what to do with it. You'd be going around trying to give it to the neighbours.
Nick, I'm going to give a question in actually with somebody from Graham Wood, who said he's considering increasing the number of PV panels on my roof and installing a lithium battery to store the excess electricity. What's your view on the effectiveness of this idea?
I'm going to dip out because I know very little about batteries.
So, but one thing you can do is divert the PV to your water tank. So if you do have a heat pump, you will need a hot water pump cylinder to deliver your hot water to your taps. You can't just have sort of instant hot water like you do with a combi. So you will need that. But in the summer, when you do have excess PV, that can be diverted straight to your hot water tank. So you won't have your immersion. Yeah. You will have your immersion on, but it'll be fed by
it'll be run off the PV. Yeah, you're absolutely right. I think the point I was trying to make was if you had so much that it was able to do quite a bit in the winter.
No, it definitely won't do it directly for winter. Yeah. More of balance over the year that you sell back to the grid or whatever it is.
But I'd really agree with you that it's a good idea, even before you start thinking about batteries. Think of that easy dump load. If you've got a hot water cylinder, put a solar diverter in, so it basically says to itself, we've only got the fridge on today, and we're about to export to the grid. Let's find something else to do with this electricity. Let's dump it in the hot water cylinder, and that's what it does.
Yeah, and also, you can use your electric vehicle as your battery.
Yeah. Yeah,
that's a different kettle of fish. So we won't go there.
The bottom line is that the correct thing to do is to get your ventilation in, then to seal up your house and improve the insulation to reduce your heat demand, then to put a heat pump in. It's always been the correct thing to do. But for some reason, everybody thinks solar panels is the correct thing to do. That's the last thing you need to do.
Yeah, bolt-on goodies are the last one.
Okay, great. Right, it's 5 to 9, so we're going to start wrapping up in a minute. Tracy, any questions that we might answer quickly? Do you think? Yes, no answers.
Yes, no. Let's see.
Short, something we can.
Wider to cover external insulation.
Didn't catch that. Sorry.
Do you need to make your roof wider to cover external insulation?
Yes, really. There are things called industry standard capping details, which are bits of aluminium trim, which can be used to make a roofette, so that if your roof only comes over the edge of your building enough to dump the water into the gutters, obviously your 4 or 6 inches of insulation will stick out far too far. So you can get these trims that go on, but I have seen jobs where I would not be 100% certain of them keeping moisture out for the rest of my life, certainly. The preference.
Have a look at the detailing around that. I'm just going to wrap you up, Nick, because we're getting to the end. Anything else, Tracy?
If you have a breathing internal wall, such as lime plaster on stone, does this mean you don't need so much ventilation as walls do half the work?
2.5 air changes, 1 air change every 2.5 hours, regardless of what kind of walls or roof you've got.
Okay, so that's a single word answer, no. Anything else? That's good. While you're having a look, Tracy, so if I can ask all of you quickly, one simple thing, cheap, simple, that we could all do this weekend, what would it be? Nick?
Walk around your house, look for gaps where waste pipes come out, where cables go in, look at those gaps, seal them up. Okay, Eliot?
Fix your house properly, and if you can't afford to, contact a local community organisation like Energy Projects Plus or GOLO, and get them to help you to get the grant off the council and spend it on roof insulation and some kind of rudimentary ventilation.
Florence?
You've taken the wind out my sails.
It's tricky going for being the last on that.
Yeah. Look through some of the Carbon Coop webinars and see if you can get yourselves a bit of a plan together.
Okay, and right, well,
Can I make you an offer, Lynn?
Say again? Can
I make you an offer? If Macclesfield promise to look after it, you can have my thermal imaging camera. Then if anyone wants to use it to go and have a look at their house, they contact you and they can borrow it.
Brilliant. Yeah, absolutely. We'd be, yes, I'll definitely take up that.
They're going to be horrified when they look at it, but they can borrow it.
I'm sure we'll find somebody. I think Florence can train us in how
I've got the Transition Wilmslow one behind me. So.
That would be brilliant, Eliot. Thank you. We'll definitely follow up. One of us will follow up with you. So I'm just going to say thank you so much. There are still 58 people on the call, and there was about 65, I think, the highest. So that means that most people have stuck with us, which is a real achievement. Well done, guys. So I think that if Tracy could share, we've got a find out more slide with some contacts of places to go. Nick and Florence work as independent consultants. You can track them down. There's a Carbon Co-op that Florence has mentioned in Manchester, which has some great webinars and materials. There's also some really good material on the Centre for Alternative Technology website in Wales, and they have they've got information sheets and other materials on all kinds of topics. Some of you in Mac will know that Kathy Mocky, who's a local architect, has been doing a open house on a building that she's retrofitting locally, and you can contact her through the Mactastic Facebook discussion group. And there are lots of case studies on some of these websites to have a look at. So I'm just now going to say, has this been useful? I've got a poll that I'm going to put here. Rate the discussion. Has it been useful? Tell us whether it was whether it's been confusing or helpful. And I'll just hand over to Tracy to just tell us a bit about Mactastic.
Yes, thank you. So Lynn, I think I just want to give some news about some up and coming events. So apart from tonight, next Tuesday, we have our first face-to-face meeting in St. Michael's Church since pandemic. So we're going to be getting various groups from around the patch together to provide points of access for the public to come and have a chat and find out what's happening in sort of sustainability in the environment space in Macclesfield. If you're interested in getting involved, we are looking for new trustees to help lead us forward in the next chapter of our organisation. And the other thing I just want to mention is we've had a couple of people asking if we can answer some questions and post the recording after this. So we'll look into that. And keep an eye out either on the Facebook group or on the Mactastic website, which actually I think I've put into the chat. So, but short of that, now that's. I just want to say thank you very much to our panelists and to Lynn, and for yourselves, for everyone for attending tonight, and just hope you have good luck in your projects.
Great.
Yes.
Thanks.
Very much.
Thank you for having us.
Yeah,
Yeah, cheers. Good luck.
pleasure.
I don't know if you
Worth
could.
doing.
Did you see the poll that about half the people have said it's been very useful? So there you go. Thank you, guys. And only one person, I think, has said that it's convinced them not to bother. So I think that's fine. But there is an awful lot, isn't there, to know? And it's, yeah, maybe Matt,
Straightforward.
what else we can do. So thank you very much. Good night.
Good night.
Bye.
Cheers.
Bye.
Cheers.